All right, let's put on our detective hats. We're about to crack one of the oldest mysteries out there. How do you tell the difference when two things are just connected versus when one thing actually causes another? It's a classic case, so let's get right to the evidence.
Our first case is something you've probably lived through yourself. In fact, it's a little mystery that plays out in millions of homes, maybe even this morning. So, you've got a throbbing headache. You pop an aspirin, and a little while later you feel better. Case closed, right? The aspirin did its job. Well, maybe. How can we be 100% sure the aspirin was the hero here? What if that headache was already on its way out? That's the mystery we need to solve.
To find the truth, we need to do something impossible. We have to take a little trip to a parallel universe, a world we can never actually see, but one we have to imagine to get to the bottom of this.
And this parallel world, it has a name. It's called the counterfactual. It's what would have happened if you did nothing, if you never took that aspirin. Think of it like the ghost in the machine. It's the key piece of evidence that is always missing from the crime scene.
Okay, so this right here, this is basically our case file. That solid line shows what we actually saw happen. You took the aspirin and your headache got better, landing you right there. But that dotted line, that's the ghost. That's the counterfactual path showing where your headache would have been if you hadn't taken anything. The true impact of that aspirin isn't just where you ended up. It's the gap between that reality and the one we can never see.
And this whole predicament, this whole we can't see both worlds at once thing, well, it's got an official name. It's the fundamental problem of causal inference. For any single person at any single moment, you only get to see one outcome. The other path is always hidden from view.
So if we're always missing this crucial piece of evidence, how do our detectives, our researchers, even begin to solve the case? Well, they use a special framework to organize all the clues.
It's called the Potential Outcomes Framework, and it's a really powerful way to think about this stuff. All you do is imagine that for every single person, there are two potential realities existing at the same time. Their outcome if they get the treatment, like taking an aspirin, and their outcome if they don't. Two potential paths forward. And get this, the true, actual causal effect is just the difference between those two states. It's what really happened minus what would have happened. It's simple subtraction, right? Except one of those numbers is a ghost. It's forever invisible to us. Okay, before we go any further, every good investigation needs ground rules. And for this kind of detective work, there's one really big one. The no spillovers rule. This rule, which has a fancy name, sattva, is actually pretty simple. It just means that for our investigation to be clean, my outcome can't be affected by whether you get the treatment. In other words, you taking an aspirin can't have some weird spillover effect that magically cures my headache. Our cases have to be totally independent.
All right, with the rules in place, it's time to meet the main villain of our story. This is the culprit that's always trying to mislead us, to make mere correlation look like causation, and its name is selection bias.
Now, on the surface, the solution seems obvious, doesn't it? Just compare the people who took aspirin to the people who didn't. See which group feels better. Simple. But this comparison is actually a trap, and it's hiding the very villain we're trying to catch.
So here's the kicker. When we do that simple comparison, the result we get isn't pure. It's contaminated. That number is actually made of two parts. The true causal effect we're looking for, plus our old nemesis, selection bias.
So what is this selection bias really? In plain English, it just means that the two groups we're comparing, the aspirin takers and the non-takers, were probably different to begin with. They weren't identical, and that fundamental difference messes up our whole comparison. Think about it. Are the people who choose to take an aspirin really the same as those who don't? Of course not. The people reaching for that pill probably have way worse headaches in the first place, right? They selected themselves into the treatment group for a reason, and that very reason throws our entire investigation off track. So, if that simple comparison is totally contaminated, how do we ever find the truth? How do our detectives finally defeat selection bias and crack this case wide open? This is where they get really clever. Instead of trying to force a perfect experiment in a lab, they go out into the real world and look for situations where the world has already done the experiment for them. They find what's called a natural experiment. So here's how it works. A researcher might find some kind of arbitrary dividing line that exists in the real world, maybe a historical boundary in a city. Then they can compare people who live just on one side of that line to people living just on the other. And here's the magic trick.
The key assumption is that those neighbors are pretty much identical in every way, except for the one thing that the boundary changes, like their access to green spaces or something.
And that's the genius of it, because people didn't choose to be on one side of the line or the other. We've neatly sidestepped our villain. We've eliminated the selection part of selection bias. The two groups are finally comparable, and it means any difference we find between them is much, much more likely to be the real deal, the true causal effect. We've isolated our suspect.
So there you have it. You've got the detective's toolkit. You know about the hidden world of the counterfactual. You know the name of our #1 suspect, selection bias, and you know the secret to cracking the case. So the real question is, now that you know what to look for, where are you going to see correlation out in the wild, wearing a mask and pretending to be causation?